Welcome back to the e-learning course 4, Derivatives and Risk Management. In session 3.2 of lesson 3, we will provide some insights how interest rate risk can be hedged. For that purpose, we will rely on the concept of duration. If you never heard of duration before, don't worry. I will show you how to compute duration. However, if you're eager to learn more about duration in particular and fixed income securities in general, a more comprehensive discussion of these topics is provided in Course 3. The learning goal of this session is to understand how to hedge interest rate risk. Note that the topic is quite complex and we only consider a few aspects of it. The probably most straightforward way to illustrate interest rate hedging is by means of an example. In this context, we use an immunization approach that ensures that the change in the interest rate won't affect the value of a portfolio. From a practical perspective, managing interest rate risk by matching duration is very appealing, and the idea behind the concept is pretty simple. Duration matching requires that the duration of assets be matched with the duration of liabilities. Potterton Leasing has acquired a warehouse and leased it to a manufacturer for fixed payments of $2 million per year for 20 years. However, the lease cannot be cancelled by the manufacturer, which implies Potterton has a safe fixed income equivalent asset. Suppose the interest rate is assumed to be 10% and the term structure of interest rate is flat. Moreover, in order to keep things simple, we don't care about taxes. Since the lease has the characteristics of a fixed income security, we can use the simple present value formula to discount the corresponding cash flow stream. In this example, the present value of all future payments is $17 million. The lease exposes Potterton to interest rate risk. If interest rate increase, the present value of the lease payments falls and vice versa. The question now is, how is it possible to hedge the interest rate risk inherent in the lease? Using duration matching, the company has to issue debt with the same duration as the lease payment to offset interest rate risk. It is important to note that duration matching is a dynamic hedging strategy which requires to adjust the position when interest rates fluctuate by large amounts. As you might recall from Course 3, duration is defined as the weighted average time until cash flows are received and is measured in years. This implies that duration expresses the interest rate sensitivity of a bond issue in a single figure. In our example, duration of the lease payment is 7.5 years. Suppose now that the CFO of Potterton finds it convenient to raise $17 million by issuing a zero-coupon bond with a maturity of 7.5 years. Note that the bond has only one cash payment and therefore a duration of 7.5 years. The question that you might ask now is whether Potterton is really hedged against interest rate risk. To answer this question, take a look at the following graph, which plots the present value of the lease as a function of the interest rate. As you might recall, there is an inverse relationship between the present value and the interest rate, meaning lower interest rates imply higher present values. Now let's add the 7.5-year zero bond to the graph. As before, the present value curve is downward sloping and convex and comes down steeply at low interest rates but flattens out at higher interest rates. When we compare now the slopes of the two present value curves, we observe that the slopes are identical at the current 10% interest rate because the duration is identical at this particular rate. The graph should as well provide some insights that the hedge is not zero maintenance. When you compare the two present value curves, you recognize that the 7.5-year zero has less curvature than the present value curve for the lease. This implies that the zero has lower duration at lower interest rates, where the slope is more shallow, and higher duration at high interest rates, where the slope is more steep. From a hedging perspective, this means if interest rates move much higher or lower than 10%, Potterton's CFO will have to reconsider and reset the hedge. Moreover, the hedge has also to be reset even if interest rates don't change, due to the fact that the duration of the 7.5-year zero will decrease faster compared to the duration of the 20-year lease. After having carefully studied session 3.2, please start with the review question.